Okay, lecture 6. We're going to start chapter 2, and we're going to get deeper into logic in this chapter. Okay, I want to remind you of a definition. A statement also called sometimes proposition. Okay, is a sentence that is true or false. But not both. Okay, that's what a statement is, or a proposition. That's what it is. Okay, and we've seen plenty of examples of that so far. Let me give you a new definition here for the word argument. An argument is a sequence of statements aimed at demonstrating the truth of an assertion. And that assertion would also be a statement. Okay? All right. And I want to put in parentheses here. The assertion at the end is called the conclusion. And the statements that precede it are called premises. Okay, so let me give you an example of an argument. If logic is easy, or I will study hard, then I will get an A in this course. That's the first statement in the argument. Okay, second statement. I will study hard. Okay, then the last statement, therefore, I will get an A in this course. Okay? So you see in this case, this statement here, whoops, that statement is a premise, and the second statement is a premise, and the last statement is the conclusion. Okay? That's a basic argument right there. If logic is easy or I will study hard, then I will get an A in this course. I will study hard. Therefore, I will get an A in this course. Okay? Now, let's look at it more closely, okay? So, look at the first statement. Let's look at this here. So I claim that that statement is made up by connecting a bunch of smaller statements together. Okay? So let's see if we can find the smaller statements that are inside of that big statement. So here's what I think. I think this is a statement right here. Logic is easy. Don't you agree that that's a statement? It's either true or false. Okay? Now that depends upon, of course, the word easy has to be well defined. We all have to agree upon what the word easy means. But assuming that that has been agreed upon, then logic would either fall into that category or it would not. Okay, so that's one statement. Here's another statement that I see. I will study hard. That's a statement. It's either true or it's false. Either I will study hard or I won't study hard. Okay? And I see one more statement inside of that first statement there of the argument. And that is, although I do want to take this word I here and move it down right here. Okay, so here's another statement that I see. I will get an A in this course. Either you will or you won't. That's either true or it's false. Okay? So you see that first statement is actually made up by connecting three statements together. So that is what's called a compound statement. Okay? Now the second statement is not a compound statement. It's just a single, simple statement. And in fact, it's the same one that showed up in the middle of the first statement. I will study hard. Okay, and the third statement, which is the conclusion, is not a compound statement. It is just a simple statement. I will get an A in the course. The word therefore there is not doing anything logical. In fact, you could leave it off entirely. That is the same argument. The presence of the word therefore or deleting the word therefore does not change the argument at all. Okay? All right. Now, these words are called connectives. I will circle the connectives. Okay? Or is a connective, and it is connecting the green statement with the blue statement. Okay? And when I connect those two, then I get a statement. Logic is easy or I will study hard is a statement itself. It's either true or false. Okay? And then the pair of words, if then, together, they are called a connective as well. Okay? Because they connect the statement, logic is easy or I will study hard, with the statement, I will get an A in the class. Okay? Now, we can use symbols to represent the form of this argument. Okay? Without, so what I'm trying to say is, if you wanted to just study the logical form of the argument and not worry about the actual words, but just study the logical form, okay, then we can do that. We can replace the words with symbols. And so that's the first thing I want to do is introduce you to what's called a statement variable and what's called a statement form. Okay, and then we'll put those together, and then I'll show you what's called an argument form. Okay, so the statement variable is it's a letter usually, but you could use some other symbol. So I'll write, wait, that doesn't look right. There we go. Okay, a letter or symbol used to represent a statement. Okay, so let's go back up to that argument and look at what I underlined in green. Logic is easy. Let's just call that P. P is going to stand for logic is easy. Okay? It could stand for something else. That's called a statement variable. The statement variable itself is neither true nor false. It's just a letter. Okay? The variable itself is not true. It's not false. When you replace that variable with an actual statement, the statement that you replace it with is either true or false, but the variable isn't. Okay? Let's look at the one in blue, and let's call that Q. Now, if you ever hear us saying P is true or Q is false, okay, what that really means is it means that P is a variable that is standing for a statement that is true. It doesn't mean that the letter P is true. It means that the statement that P stands for is true. Okay? All right, and let's see the one I underlined in pink. Let's call that statement R. Okay? See that we have Q again here, and we have R again here. So that argument could have been written like this, and then you'll see that this is a lot shorter. I could have said, if P or Q, comma, then R. period. Second statement, Q, period. Third statement, therefore, R, period. Okay? So that's what we would call the argument form, you see. Now, again, that by itself is neither true nor false. The statements there are neither true nor false. Okay, by the way, when we talk about an argument, there's no such thing as an argument being true or false. The words used for an argument is valid or invalid, and another one is sound or unsound. But you never say true or false for an argument. You say true or false for statements. Okay, now, these things in here are technically not statements. If P or Q then R, that's not a statement anymore, okay? Because P, Q, and R are not statements. They're statement variables. So they are neither true nor false themselves. So therefore, if P or Q, then R is neither true nor false, because it's technically not a statement. It's what you call a statement form. Let me write that down. Whoops. Okay, a statement form or propositional form is an expression made up of statement variables and connectives. I'll say logical connectives. Okay. And then there's more to it. So a statement form is not a statement itself. Okay. It's neither true nor false. For me to say if P or Q then R, that by itself doesn't make any sense one way or the other. Okay, it only makes sense when you actually plug in specific statements in place of P, Q, or R. Then it would make sense, and you could talk about whether what you have is true or false. Okay, but with the variables in there, it's neither true nor false, which means a statement form is not a statement. Okay, but there is more to this definition. Let me put a comma, and the second part is that becomes a statement when actual statements are substituted for the variables. Okay? So let's shrink this down a bit. So this thing down here, that's composed of 3 statement forms. Okay? If P or Q, then R is a statement form, Q is a statement form, and therefore R is a statement form. They're neither true nor false. Okay? But up here, I have substituted actual statements in place of the variables. In place of P, I've substituted the statement. Logic is easy. And we don't need to argue about whether that's true or false. The point is, it's true or it's false. It's not the point of which one is it. It's just the point that it is one of those two. That's what makes it a statement. Okay, so logic is easy as a statement. And I replaced P with logic is easy. I will study hard as a statement. And I substituted that actual statement in place of the variable Q. And I will get an A in this course is a statement that I've substituted in place of R. So these things written up here are statements. These here are statement forms. Okay, this is really important for you to understand the language and use it properly. You won't do the logic correctly if you don't use the language properly to start with. Okay? All right, now let's zoom back in on this down here. We can even shorten this more because we even have symbols for the connectives as well. Let's see here. This connective OR is the symbol like that. And this connective, which is actually a pair of words, if then, together, those are use the symbol of an arrow. Okay, and even the word therefore has a symbol which is 3 dots. So I could write that like this. I'll show you, and you'll see it. It takes very little space. I could write the whole thing like this. That's P or Q. I want to make it very clear that that's not a U. It's more like a V. I hope that's clear, okay? So that's P or Q. Then if I do this, if I put parentheses around that and draw an arrow to R, then that is a way of representing if P or Q, then R. Okay? So that represents this whole thing here. That whole statement, you can see its logical form right there. You can't see if it's true or false down here, but you can see its logical form. And that's why that's called a statement form, because it shows the logical form of the statement. Okay? All right, and then let's continue. Then I'm just copying the logical form of that argument up there. So what would be next? Next I would just write Q. And then what would I write next? At the end I would write therefore. Hang on a second, let me do that better. R. Okay? So, up here, we have an argument made up of 3 statements. The first one is called a compound statement, because that first statement up there is made by connecting three statements together. Okay? Down here, I have symbols that show me the logical form of the argument up here. Do you see how that is? This down here doesn't tell me what the argument up above says, but it shows me the logical form of the argument up above. Okay? And that's what we're going to learn throughout this class, is how to work with all these things. And it's going to be really important for you to use the language properly, to learn the language properly, learn what the words mean, and use them properly, learn the correct symbols, and learn how to operate with them. Okay? Okay, now, so what I have shown you here is I've shown you what is going to take us weeks, okay, to get down. So what I want to do now is I want to I've shown you the big picture, okay? Now I want to start small again with specifics. Okay, so I'm going to start teaching you a bunch of logical connectives. I've already shown you some up above, like or and if then. Okay, well, I'm going to go through a list of a bunch of them now. Okay. So these are just some logical connectives and their symbols. Okay, we'll cover several right now and then we'll learn more as we go along. So the first one to do is called negation. Here I'm going to do this sort of like a chart. Okay, I'm going to write the name, and then I'm going to write the word you should think of, or maybe I'll do it like this. I'll say corresponding word. How about that? And then I'm going to show you the symbol. And then I'm going to show you how it's used. I might need to shrink this down a bit. Or here, let me do this. I don't really need to shrink anything down. I just need to move things over. Okay, so the first one is called a negation. And the word you should think of when you see a negation is the word not. And the symbol for a negation is that. Let me do that a little bit better. I always mess up at the beginning. You don't have to stress about, like, you don't have to be a perfectionist, but just because this is the first one, I want to write it well. Okay, now in computer programming, a lot of times you'll see this instead. Okay, not with the parentheses. Here, let me take the parentheses off. So It would be either one of those two symbols. Okay? And how is it used? It's used like this. Okay? That's how it'd be used. That would say not P. I mean, it's technically called the negation of P, but usually people read it as not P. Okay? That's called a connective, even though it's not really connecting two statements together to make a new statement. It's just being connected onto a statement to make a new statement. So, like, if P is the statement, logic is easy, then the negation of P would technically be not logic is easy. But of course, grammatically, that sounds very awkward, so that's not how we would say it in the English language. If P stands for logic is easy, then the negation of P would be logic is not easy. Okay? And I would caution you against saying logic is hard, because then we have to get into the whole argument of, is something not easy, then does that mean it's hard? And it's best not to get into there, because that'll draw us away from the actual important parts. Okay? All right, so negation, that's the first connective. And I do want to point out something, that this right here is not a statement, it's a statement form. It does not have any meaning on its own. It's not true or false on its own. It becomes true or false when you substitute a statement in for the variable P. So when I substitute logic is easy, then I get the negation of logic is easy, and that's either true or false. Okay? But when I just have not P and I haven't put a statement in for P, then what I have there is neither true nor false. It's just a couple of symbols on a piece of paper. Okay? All right, next one. It's called a conjunction. The word you should think of with conjunction is the word and. And the symbol is that, and it's used like this. It is used to connect two statements or statement variables. Okay? If you use a conjunction to connect two statements, then you get a new statement, which is called a compound statement. If you use a conjunction to connect two statement variables, then you get a statement form. Okay? And the way you would read it is you would read it as P and Q. All right, the next one's called a disjunction. And that should elicit the word or. And you've seen this one up above. That's the symbol. Okay? So it's used like this. To connect two statement variables to get a statement form, or you can use it to connect two statements to get a compound statement. And you would read that as P or Q. Now, do not get lazy and start writing this and this, because they will be marked wrong. That means something different. That means intersection and union, not conjunction and disjunction. Okay, they should come to a point. It's two straight lines connected at a point. There is no curved lines in either of those symbols. Okay, now there's going to be more logical connectives, but for right now, let's just start with these three: negation, conjunction, and disjunction. Okay, I want to move on now, and I want to show you what's called a truth table. Let me write it down. A truth table is, sorry, I shouldn't say is yet, there's more. A truth table for a given statement form. Displays the truth values that correspond to all possible combinations of truth values for its component statement variables. Okay, so that's a lot to take in. So let me show you what that means. So let's look, just for right now, let's look at this, the conjunction of P and Q. Okay, now what is that? You should be practicing getting this language down correctly. Okay, so what is that? That is a what? Okay, the correct answer to that question is that is a statement form. Okay, it is not a statement, it is a statement form. Is that true or false? Well, that's a flawed question. It is neither true nor false because it's not a statement. It's a statement form. Statement forms aren't true or false. They could be either. It all depends upon this. It all depends upon whether you substitute a true statement for P or a false statement for P, and also whether you substitute a true statement for Q or a false statement for Q. So you see, the truth value of that depends entirely upon what you substitute in place of P and in place of Q. You have to, in order to get a truth value for this statement form, you need to turn it into a statement, which means you need to substitute statements in for P and Q. And then the statement form will become a statement, and then it'll be true or false. What we want to know is this: what's the relationship between the truth values of the statements substituted into P and Q? How are those truth values related to the entire statement P and Q? Okay, you see what I'm saying? So let me summarize. That statement form right there, P and Q. That itself is neither true nor false, but it will become true or it will become false if we actually put words in place of P and Q. Okay? So depending upon what we put in, that might be true and it might come out false. What I care about is how does the truth or falsity of P and Q affect the truth or falsity of P and Q. So what we do is we make a table. So let's put a table in here. And for this one, I'm going to need 3 columns and, well, it's going to be 3 columns and 4 rows, but then there's a header at the top. So I'm going to put in 5 rows. Well, you can't see those lines very well, so I'm going to draw it by hand. Okay, and what I'm going to do is I'm going to put a column for P and a column for Q, and then a column for the conjunction of P and Q. Okay? And you don't have to separate with vertical lines every single column. You can if you want, you're welcome to, but I'll just tell you that you don't have to. Usually people will put all of the variables and then a vertical bar. Okay, now here's what you do. P itself is neither true nor false. It could be either one depending upon what words you substitute in place of the letter P. Okay, and same with Q. So one possibility is I might put a true statement in place of the letter P and a true statement in the place of the letter Q. That's one possibility. Okay? Or I might put a true statement in place of the letter P and a false statement in place of the letter Q. Or I could put a false statement in for P and a true statement in for Q. Or a false statement in for P and a false statement in for Q. And doing either one of those will make P and Q into a statement, which means it'll be either true or false. And I need to show you right now the truth or falsity of P and Q as it relates to the truth or falsity of P along with the truth or falsity of Q. Okay, and here's how it goes. If P and Q both, I'm just going to say it like this. I'm going to say if they're both true. What I really mean is if I put true statements in place of them. Okay, but that's too cumbersome to say. So I'm going to say if they're both true. Okay, then P and Q would be true. And in all other possible combinations, P and Q comes out false. And what I just wrote there, that's called the truth table for P and Q. Okay? Or even more technically, it's the truth table for the conjunction of P and Q. Okay, let's do the truth table for the disjunction of P and Q. And by the way, let me say this. There's nothing that we said up until this point that would have told you this. Okay, that's new information that I'm giving you. I'm telling you right now. That's how P and Q operates. Okay? So you should not be asking, where did he get those from? You should not be asking that. Okay? It's like when you were in first grade and you were taught 1 + 1 = 2. I mean, it's just a fact, right? You didn't say to the teacher, well, wait a second, how did you figure that out? It's just what it is. Okay? Same thing here. So you don't try to figure out where I got these T's and F's from. What you do need to do is you need to memorize the pattern of those T's and F's in relation to these T's and F's. You can put the rows in any order you want, as long as when P and Q both have a T, P and Q should have a T. And in all other cases, P and Q should have an F. Okay? All right, so let's do the truth table for disjunction. So that looks like this. If P and Q are both true, then their disjunction is true. If one of them is true, then the disjunction is true. The only time the disjunction is false is if both P and Q are false. Okay? And that table is just a fact that you need to memorize. And you do need to memorize it. If you don't memorize it, you won't get any of the stuff that we do after this point. Okay? All right, and let's do the truth table for negation, because I introduced you to negation, but I never showed you the truth table yet. I sort of skipped it, so let's do that. Now this one doesn't need to be as big, because we're just going to have P. There's only one component variable here, is P, and then we have the negation of P. Okay, and here's how this works. If P is true, then the negation of P is false, and if P is false, then the negation of P is true. Okay? All right, this is really, really important stuff. You have to get this stuff down as we go through it, or else you're just going to be lost the rest of the semester. So take this very seriously, okay? The words are important. We need to use the language correctly at the same time as using the symbols correctly. Okay, now the title of this lecture, if you saw at the top, was Logical Form and Logical Equivalence. So we didn't actually get to logical equivalence yet. We'll do that in the next lecture. We really only talked about logical form, but we talked a whole lot about it, and all sorts of different things that go into that, and a lot of definitions here, and truth tables. Very important, but we haven't done logical equivalence yet, so that'll show up in the next lecture. Okay, have a good afternoon.